Welcome to our comprehensive Docker interview preparation guide. Docker is a containerization technology that has revolutionized how applications are developed, deployed, and managed. In this video, you will learn the fundamental concepts of Docker that are commonly asked in technical interviews. Topics include Docker images, containers, Dockerfile creation, volume management, networking, and application packaging. These concepts are essential for any developer or DevOps engineer working with modern application deployment strategies. Docker is a containerization platform that uses operating system-level virtualization to deliver software in lightweight packages called containers. Unlike traditional virtual machines that require separate operating systems, Docker containers share the host operating system kernel, making them much more efficient. The key benefits of Docker include portability across different environments, consistent application behavior from development to production, reduced resource overhead compared to virtual machines, and faster startup times. Docker enables developers to package applications with all their dependencies into a single container that can run anywhere. Docker architecture consists of several key components that work together. The Docker client is the primary interface that developers use to interact with Docker. It provides command line tools for building, running, and managing containers. When you type Docker commands, the client communicates with the Docker daemon. The Docker daemon, also called Dockered, is the background service that does the heavy lifting. It manages Docker objects like containers, images, networks, and volumes. The daemon listens for Docker API requests and handles all container operations including building, running, and distributing containers. Understanding the difference between Docker containers and virtual machines is crucial for interviews. Docker containers share the host operating system kernel, making them lightweight and fast to start. They have minimal resource overhead and can start in seconds. Virtual machines, on the other hand, require full operating system virtualization. Each virtual machine includes a complete operating system, which consumes significant memory and storage. Virtual machines take much longer to boot up, often requiring minutes. Containers are ideal for microservices and applications that need quick scaling, while virtual machines provide stronger isolation for different operating system requirements. Docker images are read-only templates used to create containers. Think of an image as a snapshot that contains everything needed to run an application: the application code, runtime environment, libraries, dependencies, and system tools. Images are built using layers, where each instruction in a Dockerfile creates a new layer. This layered approach makes images efficient because layers can be shared between different images. Common Docker image commands include Docker images to list all local images, Docker pull to download images from registries like Docker Hub, and Docker build to create custom images from Dockerfiles. Containers are runnable instances of Docker images. When you start a container, Docker creates a writable layer on top of the read-only image layers. Containers are isolated from each other and the host system, but they are much lighter than virtual machines. Each container has its own file system, network interface, and process space. Essential container commands include Docker run to start new containers, Docker ps to list running containers, Docker stop to gracefully stop containers, and Docker rm to remove stopped containers. Containers can be started, stopped, moved, and deleted easily. A Dockerfile is a text file containing step-by-step instructions to build a Docker image. Each instruction in a Dockerfile creates a new layer in the image. The from instruction specifies the base image to start with. wrkdir sets the working directory inside the container. Copy transfers files from the host to the container. Run executes commands during the image build process, typically used for installing dependencies. Expose declares which ports the container will listen on. cmd specifies the default command to run when the container starts. Dockerfiles enable reproducible and automated image builds. Docker volumes provide persistent data storage for containers. By default, any data created inside a container is lost when the container is removed. Volumes solve this problem by storing data outside the container file system. Volumes can be shared between multiple containers and survive container restarts and deletions. There are several types of volumes. Named volumes managed by Docker, bind mounts that map host directories to container paths, and TMPFS mounts for temporary data. Volume commands include Docker volume create to create new volumes, Docker volume ls to list volumes, and Docker volume rm to remove unused volumes. Docker networking enables containers to communicate with each other and with external systems. Docker provides several network drivers for different use cases. The bridge network is the default network that allows containers on the same host to communicate. Host network mode makes the container use the host's network directly. Custom networks can be created for better isolation and communication control. Network commands include Docker network create to create custom networks, Docker network ls to list all networks, Docker network inspect to view network details, and connecting containers to specific networks using the network flag during container creation. Congratulations! You have completed the essential Docker concepts for interview preparation. You have learned about Docker architecture, the difference between containers and virtual machines, how to work with images and containers, Dockerfile creation, volume management for data persistence, and networking concepts. These fundamentals form the foundation of containerization technology. Practice building your own Dockerfiles, creating containers, and managing volumes and networks. Remember that hands-on experience is crucial for mastering Docker. Good luck with your interviews, and continue exploring Docker's advanced features as you grow in your DevOps journey.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.